So today we got problem 3347, maximum frequency of an element after performing operations 2. You are given an integer array nums and two integers k number. You must perform an operation, select index that was not selected and add minus k to k to it. Maximum possible frequency of any element in nums after performing the operations. Okay, so if I select like 11, I can put all numbers that are this and then all numbers that are larger, and I can do up to one of them. Okay, well, my intuition is that this kind of sucks because if you have many elements there. Okay, let's take a calculator. Because for this element, it's okay, 10 to 9, so potentially the entire array. So basically you want to increase some elements to left and decrease some to right. And then the question is, I mean, does it really matter which you do? You just take minimum of what you can and how many operations you have. And that's it, I think. So, whatever. But ties are gonna make a little problem. But not really. If I compress the ties, then I can do this approach. Okay, should work, I think. And I think I did some similar problem, but I have not solved this, so I guess I have not done this exact problem, so I need it sorted. So let's get counts and then so here we get counts, here we build a and then now that we have that, we start with L I R is this, and then what we want to do, I is under N. Actually, we set N now, and we have answer, and then I plus plus. Now what we want to do, while L is under I, and technically that's not necessary, so while nums I minus nums L over K L plus plus, and while R is under N, L nums R minus nums I smaller than or equal to K R plus plus. Oh, and we need to do left count, right? So I need to have some sort of an L count. Air count is this, so we want to throw that out. L count minus equals AL plus plus second. I guess, and then we want to do air count plus equals AR plus plus second. I don't have to do this, and I use prefix ans. No. Fair enough. So we just do like L++ and then R++ and then ans plus equals or no. So how many we can? So int available is prefix R minus prefix L minus count nums I. Okay, and now ans max ans int count nums count plus min available maybe this will work. I'm not sure though. Immediately. Okay, some cases don't pass. Oh shit, that's an edge case I didn't think of. Okay, so let this be one answer. Instead of doing it somehow smartly, let's do it this way. First, here we assume we pick one of the elements. Then, only then, we assume that, okay, we make the element to a number which is not one of those numbers. In that case, we do this. Basically we have a window of size 2k and we just want to know number of elements in there. So while r is n and nums are, but I don't have nums, or do I? A first I have no clue how this even worked. What the hell? Damn, that's wild. Okay. A first AL first smaller than 2k R++ ans max ans min pref R minus pref L so this and num operations. fair enough. Let's see if this works. Okay, that worked also. Let's see if we made any progress. Oh, that was quick, 10 minutes. Okay. 2 pointers. So either we reduce elements to reduce some subarray to an element of the array to or the number with same frequency number to which we can reduce most elements is not in the array. In the first case, we find all elements let x be the we find all elements element of the array, we find all elements I'm surprised this worked so quickly. We find all elements in range x minus k, x plus k. Then know the number, okay, so the maximum number of which are the only elements reducible to x. To count the max number of elements in this range reducible to x, we pick all occurrences of x and min num operations of non-x elements in range. Case e.g. when we have 562 k 42 num equal to, I don't know, 35. This is an even simpler case since we just reduce all elements in range x plus 2 times k to the same element, assuming that final element is not in assuming that final element does not occur in the range of collected numbers. How to find those ranges fast? First, we compress the input array into array of pairs, original value count to have unique values for easier manipulation, and we calculate prefix sums of summed for this new array. A sorted array of pairs. The ranges by either binary search by either binary search or simple two pointers approach. Time complexity n log n. Since we count the elements and build a new array of sorted values and then use two pointers approach twice and do O1 work for each candidate in both options of n, since we at most store the original array again in the array of pairs, and we also store its prefix sum. Okay, I can't believe that this was finally a normal hard problem. Goodbye.